Unit conversions using dimensional analysis. What's a dimension? Glad you asked. Dimensions are the units that we use when we measure things in science. For example, if you're measuring mass, you might measure things in grams or kilograms. You might measure things in pounds if you're using the British system of units. If you're measuring dimensions such as length, you're using centimeters or meters. You may also use kilometers if it's a long distance, or feet and miles. These are the dimensions we use for measuring distance. And if you're measuring something like volume, well, volume can be measured in cubic centimeters or cubic meters. More commonly, we would use something like liters, or sometimes we measure volume in gallons. These are the units or the dimensions that we use in dimensional analysis. All right, let's try a problem. It says convert 65.0 inches into centimeters. So the first thing you might be wondering is, why did I write 65.0? Why the 0 on there? The 0 is important. It tells us this is a digit that we know. In science, we call those significant digits. When you solve one of these problems, what you do first is you write down your given, the information you know. We're going to write this number as if it were a fraction. So I write 65.0 inches over 1. The next thing we do is we think about what we're looking for. So in this problem, they tell us to find centimeters. So over on the other side of my board, I've written what I'm looking for, centimeters. Now the next step is to insert a conversion factor. We're using a technique called dimensional analysis. Dimensional analysis says we're going to analyze the dimensions or the units. Since I want centimeters and I've started with inches, the technique that I use is to get inches to cross out. Inches will cancel if I write them on the bottom. A unit that's on the top of one step and the bottom of another cancels. Centimeters will not cancel, which is good because we want them left over in our answer. So now all I need to do is insert a conversion factor. And the conversion is every 1 inch is the same distance as 2.54 centimeters. Those are equivalent. So in effect, what I'm doing by putting this in is putting two things that are equivalent, or multiplying it times 1, essentially. All right, so here are my numbers. Now the math. To do this calculation, we're actually going to do something like this as you combine fractions. This is the math that I'm going to do then. I'm taking 65.0 inches times 2.54 centimeters divided by 1 divided by 1 inch. And as we said before, the inches cancel. And what's left is the product of these two numbers. We've got 1s on the bottom, so I can cancel those. And the units that are left are centimeters. So I get out my calculator, punch all these numbers in, and I get my answer. So the answer is 165.1 centimeters, but I'm going to do something interesting with this answer. According to my problem, I had 3 numbers in that measurement, 3 digits that I knew. And this also has 3 digits in it. And what that means is my answer should only have 3 digits in it. So I'm going to take 165.1 centimeters. I'm going to round that so that it has 3 digits. Call it 165 centimeters. That was fun. Let's try another one. This problem says convert 50 pounds to kilograms. So we're going to use the same strategy we used last time. I'm going to start by writing down the given. Notice that I wrote it as 50 pounds with the units over 1. The next thing I'm going to do is I'm going to write down where I'm going with this problem. What am I looking for? So So over on the right side of my problem, I left a little room for a number and I wrote the units kilograms. The next step is to insert a conversion factor. Notice that we're multiplying our conversion factors. So the conversion factor is written like a fraction with two things that are equivalent, one on the top and one on the bottom. You can actually flip that conversion factor either way to meet your needs. When I put a conversion factor in, I'm going to put pounds on the bottom so that they will cross out. I'm going to put kilograms on the top. And now I've got to look up a conversion factor. That conversion factor says that every 1 kilogram is equivalent to 2.20 pounds. Once again, we've got this problem set up so that some units will cancel. My pounds cross out, kilograms are left for my answer, and my answer will be whatever you get when you divide. Last time we multiplied two numbers because they were both numerators, but this time I've got one number on the top and one number on the bottom, so we divide 50 by 2.20. And the answer is 22. Point 7272727, and of course we're not going to write down all of those digits, so we'll round our number off. Any ideas how many digits we will keep? That's right, we're keeping 3 digits because there are 3 digits in this measurement and 3 digits in this measurement, so we'll round our answer so that it has 3 total digits. It means we'll keep the 2, 2, and the 7. We'll check the next digit, and if it's higher than 5, we'll round, which it isn't. And so we'll just get rid of the rest of these, call it 22.7 kilograms. 22.7 kilograms. Great job. Let's try another one. This problem says that we need to convert 350 milliliters into gallons. So let's use the same strategy we've used to solve this problem. There, I've written down the units that I know, milliliters, along with my measurement. And over on the other side, I'm going to write down the units I'm looking for. Now I happen to know this is going to take us 2 steps. That's why I gave myself a little extra room. Sometimes you don't always know that, and that's okay, that's part of learning. The next thing I'm going to do is I'm going to convert from milliliters into liters. You might be wondering, well, why didn't you go from milliliters to gallons? And the answer is very simple. I don't know how many milliliters are in a gallon, but I do know the liter to gallon conversion. So here's my strategy. I'm going to turn my milliliters into liters with this step. You see, 1 liter is equal to 1,000 milliliters. Now, my milliliters have crossed out, and I've got liters. I'm just going to add another step to my problem and get the liters to cross out and give me gallons. Now, this conversion factor I do know. The conversion that lets me go from liters to gallons says that for every 1 gallon, there's 3.785 liters. So these are all the steps for my conversion. I cross out liters. Notice that the units have all crossed out except for these, gallons. And as far as my calculation goes, I'm going to take 350 and divide it by 1,000 and divide it by 3.785. Let's try the calculation. .0924702777. And once again, I'm not writing down all of the digits. I'm going to round this answer off so that I only have, I'll keep 2 in this answer. And call it .092 gallons. Man, we're getting good at these. We're going to try this one next. For example 4, it says to convert 525 OZ to kilograms. What's an OZ? Right, those are ounces. Now, before we do this problem, we've done a couple already. I want you to pause this video and I want you to try solving this problem on your own. When you're done, you can finish playing it and we'll compare answers. Go ahead, pause the video. I'm waiting. Well, it turns out this is another problem that's going to take me 2 steps to get to my answer. I'm starting with 525 ounces and I'm trying to get to kilograms. So the first step of my problem is to turn the ounces into pounds. And you're asking, Mr. Erickson, why didn't you go from ounces to kilograms? And the answer again is, I didn't know the conversion factor. But I can go from ounces to pounds, and I do know a conversion factor that goes from pounds to kilograms. So now I just have to look up some conversion factors and figure out the ratio. For every 1 pound, there are 16 ounces. And then over here, I'm going to put a conversion factor that says for every 1 pound, it's, let's try this one, for every 1 kilogram, it's 2.20 pounds. All right, so now all that's left is a little calculation. We crossed out our ounces and our pounds. We had to divide this number by these 2 numbers, and again, you divide if they're on the bottom. If there's a number on the top, you multiply. We're dividing 525 by 16 and also by 2.20, and then we'll get our answer. And again, just for fun, I'm writing out all the digits my calculator gives me, but I'm always having us go back and take a look at the numbers that we started with and round off. Our starting measurement had 3 digits, so my final answer will also have 3 digits, and I will call that 14.9 kilograms. Good job. All right, so we saved the hardest problem for last. Let me read the problem with you and we'll see if we can figure out how to solve this one. It says there's a car that gets 33.4 kilometers per liter gas mileage. What is its efficiency in mpg? I read about this car and I thought that's pretty interesting that a car can get that good of gas mileage, 33.4 kilometers per liter. You might be thinking, 33.4 kilometers, big deal, my Prius gets like 50. Well, take a look at the units. This says kilometers per liter. It's kind of hard to compare this car to a Prius because the Prius gas mileage you gave me was in mpg. So let's convert. Now this conversion is a little more complicated because there's 2 units in this. It says it gets 33.4 kilometers / liters. This is the way that I write this ratio when I solve my problem. I write 33.4 kilometers for every 1 liter. 33.4 kilometers per liter. Now, I've got to eventually turn this into this. We've got to get an answer that's in miles per gallon. So we do some converting. We're going to do both conversions together into one big problem. We're not going to make this more complicated than it needs to be. The first thing I'm looking at is those kilometers that's on the top, and I wish it had miles on the top. So watch how we convert that. You probably figured we were going to put the kilometers on the bottom so that they cancel. In my conversion factor, if I put kilometers on the bottom and miles on the top, that's going to help me get a little closer to my answer. Now we do need to look up the ratio, the conversion factor for miles and kilometers, and 1 mile is equivalent to 1.609 kilometers. Now that's a good start, but if I stop right there, I did not get my answer, I would end up with miles per liter. I wanted my answer in miles per gallon, so I still need to take care of this unit. And watch how we get the liters to cancel. Over here, I'm going to put in a conversion factor with liters on the top and gallons on the bottom. Wonder why we put liters on the top? Of course, we want the liters to cross out, so if they're on the bottom here and the top here, they'll cancel. We put gallons on the bottom, which is great because we need gallons on the bottom in our answer. So the units look good. I just need to look up one more conversion factor, and that conversion factor says 1 gallon is 3.785 liters. All that's left to do is the math. So we take out our calculator and we multiply these two numbers on the top. We divide this number on the bottom. We never worry about all the ones in our problem because they're not going to change our answer. Let's try the calculation and see what kind of gas mileage this car's getting. That can't be right. It says 78.5699192. I'm going to round that to 78.6. I bet that beats your Prius. All right, so the last thing I'd like to do is answer two common questions that my students ask me. And the first of those questions is, why bother with this? I've got a phone, I've got a computer, I can just type things into Google and get answers. I could literally type in 33.4 kilometers equals how many miles, and Google would spit out the answer. Well, the reason I'm having you do this is I want you to be able to think and figure things out, not to rely on your computer or your phone to do all of your thinking for you. The second question I commonly get is, gee, Mr. Erickson, you sure made this look really difficult. Can't I just do this on my calculator without writing all of this down? I know how to do these conversions. And I bet you do. And I used to think the same thing. And I resisted and I did it my own way. And what I discovered later is I was missing a really important skill. Setting up these problems and crossing out units. We're not just doing this to make a lot of work. I'm teaching you, while the problems are easy, a skill that you're going to use all throughout chemistry, a skill that we call dimensional analysis. So I know it seems like a hassle, but I need you to show your work when you do these unit conversion problems, and I need you to cross units out and to show me what happens when you multiply conversion factors this way. So now you know how to do unit conversion problems. This is going to open up all kinds of doors for lots of chemistry calculations. But it's really important that you practice and that you cross out those units. Of course, as always, if you have any questions, ask someone smart.